Hello and welcome to the October edition of the San Francisco Bay Area PostgreSQL Users Group. We're very glad you're all here today. This meeting is being recorded, as the announcement just declared. If you choose to ask a question, your voice will be recorded. If you have your camera on, your image will also be recorded. If you don't want to be recorded, you can also type your question to the moderators or the organizers, that's what they're called here in GoToMeeting. You can type the question to the organizers and the organizers will present the question for you. Otherwise, just ping the organizers, let us know you have a question, and we'll put you in the queue and let you know when it's time to turn on your mic and ask your question. If you have any technical issues, please message the organizers and we'll help you sort them out. So today we are delighted to present PostgreSQL 14. What's new? And it's very new, just out not even quite 2 weeks, and so very, very timely. So let me introduce Christophe. Hello. Christophe has spoken for us before, and we're always happy to have him back. Christophe is the CEO of PostgreSQL Experts, Inc., a Postgres consultancy, and he is a member of the Postgres Global Development Group Infra team. He's also a PGUS web team volunteer, helping us to keep the website up and functioning. And now, Christophe, I am going to make you the presenter and turn it over to you.
There we go.
Yay.
All right. Thank you, everyone, for your patience while we sorted this out. This is the modern world where instead of bringing donuts, we bring technical problems to these. There are hundreds of performance improvements and fixes. Always read the release notes. There are the release notes, the URL for the release notes. Craig Kirstens in his blog post about Postgres 14 said it's the little things, and he's basically right. There aren't any gigantic features in this release. There's nothing like logical replication gets rolled out or partitioning gets rolled out, but there are a lot of small things that will make your life a lot easier in this release. It's a highly recommended upgrade, especially for large high connection count sites. So if you're running one of these connection count things that have a connection, have thousands, 1,000, 2,500, 5,000 connections, you want this upgrade. It has a lot of really good stuff in it. The bad news is, of course, if you're on RDS or a similar cloud provider, you'll have to wait for them to get around to porting it to their environment. But when they do, upgrade, and now is a good time to start thinking about how you're going to upgrade on that. Okay, performance, the things that are roughly categorized as performance. I would say this is the single biggest feature of 14, and it's something that doesn't really, it doesn't have a new parameter, it doesn't have a new feature, it doesn't have new SQL syntax, but the concurrency is much, much better. There are significant performance and throughputs if you have multiple sessions. The tested performance ranged from 20% to over 3 times higher transaction per second counts on very large connection counts, like if you have 10,000 connections open. This is true both if you have lots of active sessions, say 1,000 active sessions, 1,000 sessions actually running queries plus 900 not doing anything. But it also improves performance if you have a small number of active queries and a very large number of idle ones, which is a very common situation in PostgreSQL. So this by itself is a good reason to upgrade if you have a very high concurrency rate site or installation. There's also been a lot of improvement to extended statistics. Now, PostgreSQL keeps statistics on every table and every column in every table. You have a certain amount of control for what the resolution on these statistics are and things like that. But by default, Postgres does not keep any correlated statistics. So if you have 2 columns in a table that are related to each other, one example is like state and zip code are very closely related. Postgres doesn't know that unless you tell it that, and you tell it that using a create statistics command. This can be a very big improvement if, for example, you're joining in such a way that that the fact that these columns are correlated could be helpful to the planner, but the planner doesn't know that unless you tell it. The problem is that you could only do it previously between 2 specific columns, but frequently you're not querying between on an exact column. For example, you're querying on, you might use the date trunc function on a date time field and only query on the months, for as an example, a 2-month resolution. Now you can create these statistics on expressions as well as on individual columns, which can be very helpful if that's the kind of query you're running. It can the planner can also use these extended statistics in more places than it previously could. For example, a bunch of things joined by ORs can be very, very helpful. Can be used with extended statistics. Again, except for obviously if you're creating it, you need to create on the expression. But for the for using it in more places, you don't have to do anything. It just does it. There have been a lot of improvements to parallel queries. Parallel queries have been in Postgres for a little while, where it will execute some kinds of queries in parallel, like the name implies. For example, as a sequential scan, it can start up multiple backend worker processes and do the query, the sequential scan in parallel. The I/O performance on these has been improved. One common thing that is popular increasingly is to use foreign tables. Foreign tables are a table that is actually lives on a different server, and you've effectively mounted it using a foreign data wrapper locally. Previously, if you had a bunch of these and using a single query, for example, you effectively were sharding by having a table spread out across multiple servers and mounted locally using foreign data wrappers, you would have to query each individual remote table in turn, which was really terrible performance. In 14, it can fork off multiple parallel workers and query each one in parallel, which is a huge win on foreign tables. Refresh materialized view can be parallelized, which is nice. And if you write PLPG SQL functions, the query that from a return, I'm sorry, someone comment there? No, okay. The query that it runs as part of return query can also be parallelized, which is handy if there's a very large result set that comes back from that. And partitioning continues to be improved. Declarative partitioning, which was introduced in Postgres 10, is the new and modern way of handling partitions, and it's been getting better and better every release. The first one is planning performance on a large number of partitions has been improved. One of the downsides of partitioning has been that if you have hundreds of partitions, the planner has to go and consult data on each one in order to do the plan, and that can significantly increase planning time, decrease overall query performance, and that's been improved. A very common use of partitioning is for time series data, where you drop old partitions off the table in order to perhaps after archiving them. That can now be done non-blocking, which is very helpful for a very busy table, because previously it would have to take an exclusive lock on basically the entire table, entire partition set in order to drop that one old one, which is, if you're ingesting sensor data at a very high rate, can be painful. So now that's a nice improvement. And a small but very handy one for system administration is you can issue a reindex command across the entire partition set at once. So just issue a reindex on the root table and it'll do all the child tables. It doesn't currently parallelize that, unfortunately, but it does. But you only have to do one command. You don't have to figure out all the children and index them individually. This feature will require some support from clients, but when the clients sign up for it, it'll be great. libpq is the underlying C library that most applications use, most client applications use to talk to PostgreSQL. The libpq has now introduced a pipelining feature. Previously on libpq, you could send a query, wait, get back the result, but until you've gotten that result back, you couldn't send another query. Now, you can just fire. Now, if you turn on the pipelining feature, it doesn't happen automatically. You can fire as many queries as you want and get the results back asynchronously at the same time. If you're firing a lot of very small queries in Postgres, that could be helpful. Of course, if one of them gets an error along this at some point, you're going to just start getting errors back, but that's the risk that's the price you pay. This is very handy if you have a slow or high latency link between the client and Postgres. You can just keep firing queries at it, and Postgres will absorb them. Okay. That's the performance area. Now let's talk about systems administration. Okay, this may be my second favorite feature that's been introduced in 14. A very common question that everyone has, they'll look at Postgres and they'll see it's using memory, and they'll say, what is it using that memory for? And the answer up until now has been, who knows? Now we can inspect the memory that Postgres has allocated. Some of it you know for sure, like shared buffers, you know that it allocates them when the system starts up. That's fine. But the other memory, the memory that's allocated for each backend process, was completely opaque. There was no way of expecting it unless you like dropped into GDB and started groveling around, which of course is not what you want to do on a live system, and it's impossible on a hosted environment. So we get two new functions. One is a system view, which shows you all the memory contexts in the system and their sizes. For example, PLPGUSQL might be a memory context. So it'll give you an entire list of them at that point and how much they're using. You can also call a second function, PLLog backend memory contents, with a specific PID, was PID for a specific background process, and it will dump to the log what memory context that particular backend process has and their sizes at that moment. So you can actually inspect it and see what that's using. This is really nice. And especially on hosted environments where you don't have a lot of introspection into the memory of the system, this could be really, really useful. So query IDs. Everyone who's using pgstat statements probably has encountered the query ID. What it is a hash of the query normalized across parameters. So for example, if you say, select thing from table where ID equals 12 and select thing from table where ID equals 25, it will normalize those to a single hash query. The idea is you can get performance across all the queries of that type in a way that would be kind of not very useful if it separated them out as individual queries. PGStat, previously you had to do that with PGStat statements, and the only place that it was used is PGStat statements. Now, even if you don't have PGStat statements, you can turn on compute query ID, and it's calculated in the core server, even if you don't have PGStat statements installed. And it also can be emitted in a bunch of other places. For example, you can see it in PGStat activity in the CSV logs if you have CSV logging turned on. If you have explain verbose, it will show you the query ID at individual nodes, and logline prefix if you're using traditional logging format. So this is very, very nice in a way of you can introspect what a particular kind of query is doing without having to use PGStat statements. One of the reasons that could be valuable is PGStat statements itself is not free. It does introduce some overhead. It's a super useful extension, and it's great to have. But sometimes you want to turn it off because you don't want the performance hit, or you want the query ID visible in other places of the system. And here you can. That's great. There's some new and improved system views. If you use the copy command, you now have a way of checking its progress, which is really nice, with pgstat progress copy. There's pgstat wall, which will give you statistics about how many wall segments have been generated and various other wall-related parameters, which were otherwise complicated or impossible to get out of the system. There's a pgstat replication slots that can show you how much data has been pushed through a replication slot. That's very nice. pglocks now contains wait start time. This is super useful because there are a lot of transient locks in Postgres that you just don't care about. So when you're trying to diagnose lock problems, you can filter on only show me locks that have been going on for more than 3 seconds or something like that, or 1 second, and that can really reduce the amount of data you have to pull through. And pgstat database now has new columns, which include things like how many sessions have connected and disconnected, how many sections have been in error mode, and things like that. So that's very useful for monitoring purposes. For a while, we've had idle and transaction session timeouts, where a session will be automatically be terminated if it sits in idle and transaction for a while. Now, if it just sits in idle for a while, it can be terminated. This is not quite as essential as idle and transaction timeout, because sessions in idle and transaction are really bad. Sessions that are just idle are not so bad, although they do consume resources and they do hurt performance, although not as much now in Postgres 14. But you sometimes have a situation where your clients will open a huge burst of connections for some reason, and then they'll just kind of hang on to them. This will let you have Postgres clean them up rather than the client having to do so. Of course, when the client tries to use it, the client will get an error, so the client needs to recover from that gracefully. So there have been also improvements to vacuuming. The one optimization that right now only applies to typing the vacuum command, not to auto vacuum, is if there are just a few dead tuples in indexes, it'll skip the index cleanup process, figuring, I'll get to it later, next time around on vacuum. That can really speed up a vacuum operation, because usually vacuuming the indexes takes most of the time. Vacuum, especially on a very large table with lots of indexes. The other improvement is in these emergency situations where XID wraparound is starting to become dangerous. If what we've traditionally had to do is we'll see it, get an alert, and start fiddling with parameters to make auto vacuum more aggressive and to take more corrective action. Now it will do a lot of these corrective actions for you automatically. For example, it will make it more aggressive in terms of reducing the cost delay and the nap time. It will also start skipping indexes automatically, because the idea is just get the table vacuumed, get the XID age down, and then you're out of this emergency situation and you're done. So that's very nice. It has a separate parameter for setting when this emergency mode kicks in, so you can adjust it depending on how busy your system is. So this is super useful. We'll keep a lot of systems out of trouble. And we have two new handy roles that have been added. Which you can grant to a user, PG read all data and PG write all data. So everyone has had, I'm sure, if you've been a DBA on Postgres for a while, the situation that someone says, could you just create a read-only role? That seems really easy. And then you spend all this time fussing around with grant, trying to get it just right. And then someone creates a new table and they can't read that one, and it's just a mess. Now you could just grant them read all data, which gives them read access to every table in the system all the time, even new ones, no matter what. You don't have to mess with it. Really will save you a ton of time and having to fumble around with commands. There's also a PG write all data, probably a little less one you want to hand out a little less frequently, that does the same thing, but also allows you to modify the data in the tables. These do not let you automatically modify the schema in any way. You can't create new tables. You can't drop tables or indexes or anything with just these roles. So this is very handy for read-only things like someone's running Tableau against the database, that kind of thing. Okay, and now talk about improvements to SQL. The first one is Python programmers rejoice. Well, I guess Ruby does this also. Is you can subscript using keys that aren't just sequence numbers. So, for example, you can select from a JSON object using the key. That's really nice. This also works for HStore if you're still using HStore for some reason. If you're still using HStore, you probably want to move to JSONB. But so that's a very handy little syntactical addition if you're using Syntax Edition. There is a new family of types, which are multi-range types. Range types have been in Postgres for a while. They are, and the range type is what it sounds like. It represents a range of a continuous value for integers, floats, timestamps, that kind of thing. Now, for every range type, there's a multi-range type that contains multiple instances of a particular of a range. So you can have you can have multiple date time range, disjoint date time ranges, that kind of thing. They're already created for you for all the built-in range types, and if you create a new range type, which you can do in Postgres, of course, it will automatically create a multi-range type for you at the same time. And in case you're wondering, if you create one with overlapping ranges, it merges them for you, which is really very nice. So nice little feature. So if you use common table expressions, there's two common things that you need to watch out for. One, or that you need to keep in mind. One is, so if you're using a recursive common table expression, and recursive is kind of a foolish name here. They really should be called iterative, but that's SQL standard picked recursive. Both of these are kinds of expressions which allow you to do multiple passes over over the data, building out a result set. For example, you might be walking a tree, a tree structure represented inside your database, and you could use this to walk the tree structure. But there are two things you have to keep in mind. One is, do you want to do a breadth first search or a depth first search? And how do you guard against an infinite loop? Because this thing will just keep running forever. For example, you think it's a tree, but it's actually a cyclical graph. There are ways of doing it, but they all were kind of messy. For example, in this one, you created an explicit depth field as part of the CTE and then ordered by it. So that way you got the depth first search. So that's not, that works, but you had to manually do it. Now you could just tell it, I want to create an order column field for me and order by it and just do it. So you don't have to manually add it. You could just tell it what tell it both the key that you're searching on, you're descending on, and an order column. That's nice. Similarly with guarding against, infinite recursion, what you would do is build a path for yourself. For example, you could see, well, you can't see my cursor, but there's this array operation that effectively you're building the path out to, and then checking inside of the path again to see if you've already visited that row. And if you have, you know not to do it. And then creating a Boolean that says whether there's a cycle or not and all this stuff. It works, but you had to do all this manually. Now, bonk, you just tell it, here's the path of the name I want to give the path variable. Here's the Boolean I want to you give for whether or not there's a cycle, and just do all that nastiness for me. And in fact, it will add that path becomes a column in the result set, so you can interrogate the path as part of the select star. Will include the path in the isCycle field. So that's very, very nice, convenient. These are actually in the SQL standard, so we've finally implemented them. And there's lots of other stuff. But first, I will take questions.
Okay, do we have questions? Okay, from Nicholas. For the query pipelining, is that purely a client-side improvement? That is, can an updated client do this on an old server, or does it need to be the server, or does the server need to be on 14?
That is a super question, and I'm only 75% sure. I believe if you're using the version 14 libpq, the version of libpq that's part of the version 14 package, the development package, but an older server, it will work. But I would double check that. Because my understanding is it's not a protocol change, so an older server could do it as well. But I don't want to swear to that.
Okay, great, thank you. Next question. Well, there's nothing queued up in chat. Does anybody else have any questions?
There's a lot of information very fast, I understand. So if you want more detail on anything, feel free.
Yes.
You mentioned that there, sorry.
Sorry, go ahead.
I see one queued up from Gabrielle, but why don't you go ahead and finish yours, and then I'll take Gabrielle's.
Oh, sorry. You mentioned that there was a chunk that wasn't yet parallelized, and it was me. I was following slow, but what was that piece, and how might parallelizing it help?
Let me go back to the parallel query importance. Reindexing.
Okay.
It will not, like, if you have 100, let's say you have 100 child tables, it won't fork off like 12 workers and parallelize each one and rebuild the indexes on each table in parallel, which would be super nice. I am sure that seems inevitable that it'll happen at this point. but I don't think it's
Well,
implemented just yet.
I was asking because I have been trying to learn how to write C, and it's early in the 15 dev cycle, and yeah.
Patches accepted. Go for it.
Yeah.
Understand
that's why I wanted to know what the thing
that's
was.
a fairly messy part of the code. So, well, I guess as opposed to what, but there's going to be it's not going to be a trivial thing to do, or somebody would have thrown it off already. But don't let me discourage you. By all means, do so. Okay. And Gabriel's question is, what's the overhead of the memory introspection view? So they say if to implement a monitoring system, or are they primarily for spot checks? I haven't actually measured this, so again, this is a little bit speculative, but based on what I know of the implementation, they're pretty cheap. So monitoring, I wouldn't like poll them every 500 milliseconds, but for an occasional poll to say, wow, this, something horrible is happening with your memory, especially the one that gives you the whole system-wide view. I think I would say that's probably okay to do. The thing to remember about the other one is it dumps things into the log. So you don't want a 1 second duty cycle on something that's going to spew out, 80 log entries each time you call it. There's the how exactly concurrency improvements in the case of multiple idle connections works. So let me do something here, which is let's see. You can probably hear my keyboard here. I'm going to I'm going to let you read directly from the this is from Andres Freud did most of the work on this, and this is his blog post on how he did it. It's mostly related to snapshot visibility. A snapshot in Postgres is basically a consistent image of the database at one particular point in time. So for example, when you begin a transaction, it takes a snapshot of the database. Now, of course, the snapshot isn't literally grabs all the data and copies it somewhere. I think we would have noticed the performance hit by now if we did that. It's kind of a point in the transaction record to say everything before this transaction is out of consists of the snapshot. Anything that happens after this doesn't go into the snapshot. Postgres consults snapshots a lot as to whether or not a particular version of a row is visible or not because of MVCC, the multi-version concurrency control model at work. There were a lot of bottlenecks in that for historic reasons, and a lot of this work was removing a lot of these bottlenecks. So it's very interesting, and if you read it and then sort of answer any, sort of research any questions that pop up in your head as you read it, you'll learn a lot about the way Postgres works. So it's a good article. I highly recommend it.
Oh, are there other questions? I'm not seeing anything popping up in chat.
So download it, use it, play with it, install it on your laptop. And my philosophy is anytime version N comes out, if you're on version, let's put it this way: if you're on version N, when N+1 comes out, you should start planning how to upgrade to N+2. So if you're on version 12 or earlier, now's a good time to start planning. If you're on version 13, now's a good time to start planning. And if you're on version 12 or earlier, now's a good time to upgrade. So that way you don't get stuck on versions that hit EOL.
Great. Well, thank you so much. That was terrifically helpful and informative. And let's see, one last check. No more questions. So yeah, very comprehensive, and hopefully this will inspire people to download and start working with it and adding their own patches to it. Hint, hint. So again, thank you, Christophe, for taking the time to prepare the talk and be with us this afternoon. Oh wait, something just popped up on chat. Oh, just a thank you from Gerald. Yay, thank you, Gerald.
You're most welcome.
We are capturing the video. It will be posted on our YouTube channel. We will send out an email when it becomes available. I'd also like to thank the United States PostgreSQL Association, aka PGUS. We are affiliated with them, and they are the North America community recognized organization, nonprofit for North America. Why am I having so much trouble with my nose today? And we are affiliated with them, and we appreciate their involvement with us and their support of our user group. Our next pug is November 10. We need a speaker, she says, hint, hint, subtly. You probably have something to say, or maybe there's someone that you've seen do a talk somewhere else, and you could suggest them as well. Drop us a note via Meetup. We're on Twitter, and just let us in. And oh, cool, David, thank you. We'll be in touch. That's great. And again, if you've seen somebody at another pug or another conference or something, do let us know, and we'd be happy to reach out to that person, or you can make an introduction. One other event coming up, the first North American Postgres in-person event in 2 years, yay! PGUS presents PGConf New York City, December 2 and 3. The talks are selected. They're listed on the site. I don't know if the final schedule's up on site, but that has been determined. So we're very excited about that. The early bird registration has been extended to October 17. And so you can take a look at the schedule, say, yeah, I want to do that, and get your early bird discount. Also, we encourage you to book your room. The room block's going pretty fast. And because it's December in New York, rooms are going to be at a premium. So definitely book your room. And again, that's PGConf New York City, December 2 and 3. The website is 2021.pgconf.nyc. Thank you all again for your time. Thank you, Christophe, and we'll see you all again in November. Bye.